Hey guys, this is Ayush and we are going to start the Kubernetes series. So today in this particular video we'll be discussing about the introduction part of the Kubernetes. Like we will be discussing some of the things like what is Kubernetes, why it is used, and some like from where it has came, like all the things we are going to cover in this particular video. So let's start the video. So basically here you can see the title which I have is Introduction to Kubernetes. So actually I have already written some of the points for you to understand it better. So if you will go down and here you will see some of the points I have already mentioned here, like Kubernetes is nothing but the open source container management or the orchestration tool. So we'll discuss it. What is this container management later on this video? And it is also developed by the Google, like the company which everyone knows, Google, and it's written in the language called the Golang. So it is one of the language which is used or which has been used to create this particular thing, that Kubernetes, the tool. And also it is used to manage the containerized application. So if you are watching this video, so it like you might be aware of the containers. What are the containers? What is Docker? How containers is made? Everything like it, like I suppose you know it. If also you don't know, like we will cover it in this video. Okay. And also it is referred as the K8s. Why it is referred at K8? So this is the thing, like you will see between K and S there are the 8 letters. So if you will count that 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters between K and S. So that is the reason behind it Kubernetes is referred as K8. So this is one of the reason. So this is the basic overview about the Kubernetes. Okay. So let's move forward and we'll be discussing about the what is this container management and the orchestration tool. Okay. So actually Kubernetes is also one of the container management and the orchestration tool. So it is also one kind of tool which is used to manage the containerized application. Like what it will manage, it will basically it will that deploying that container, scaling, managing, and all those things, it's done by these kind of tools like the Kubernetes. So like in market we have also some of the many different tools. We have like we have Kubernetes as well, we have Docker Swarm, we have Apache, we have OpenShift as well. So there are many tools there in market, but Kubernetes is one of the very like famous tool which you can say like in like, by the way, it's developed by the Google. That's why it's a very fascinating product. Okay, in this DevOps industry. So the point here is the whatever the container is created by the developer. So to manage those containers or those images, we require the Kubernetes. Okay, so this is the reason behind whole thing, like why it came in role. So the answer is simple. It came in role to manage the containerized applications. Later we will see like what is the whole, like how it manages, what are the concepts which is required. Everything we'll cover in this particular video. Okay, so let's move forward. If you will go, I have prepared one chart. Here you will see what Kubernetes is. So Kubernetes is nothing but the container management tool. And what container management tool does, it manages the containerized application, and containerized application where it is available, like the whatever the application which is available on platform like the Docker. Like on the Docker, what happens? Many platforms, sorry, many containers are available there, or the images, we say Docker images are present there. So from there you can access that image and use it in your machine. So if you don't know the concept of the Docker, so let me tell you first about it, what Docker is simply. So what happens whenever a developer, suppose this is a project, okay, a developer is there who creates a project in Python version 2.3, okay, and this project is on machine, sorry, This project is on machine A, and now developer wants to share his project to some other team members, or suppose some other team like testing team. Now the project is going into the testing. So at that time, uh, in the testing machine, in the testing team, their computer is B, and their Python version is 2.9, and here the project comes. So in this, what will happen in this, the project will not run because the project is made on the version of 2.3. So it might be case like some dependencies may be deprecated in the version of 2.9. So it might case like the project will not work on the tester's machine. That's why Docker came in role to solve the problem, like the a quote which you might have listened, like this code works on my machine but it doesn't work on your machine. So basically to solve this problem, like code works on my machine but not on your, that's why the Docker came in the role. I hope you got it. The point what I'm trying to tell you here. So project 2.3a and 2.9b is there. Okay. So what will happen if we create one thing like the Docker? Suppose I just create one. This is suppose one Docker is Docker container I have created, like the developer created, and in that the version is same 2.3. And what will happen? The second team member, the B, he will also access the same container, and he will also like use the same container. Okay, so in that case both of the team member is using the project with the same configuration. So basically what happens whenever a container is created, so in that case similarly the thing what happens is it basically the whatever whoever is the developer what is does it just what do we say, add all the dependencies. Okay, dependencies you can you can tell, or you can say all the source codes, whatever the required data or required libraries. Okay, whatever the libraries is required to run the project, everything will be present in that Docker container. So if someone else will run that container, or will run that Docker image, so obviously it will run because it has all the configuration already installed to run it. Okay, I hope this point is clear to you about the Docker. What is a Docker? Okay, so now let me tell you about the containers, like not containers, about the Kubernetes, like how it helps the Kubernetes. So what happens the case, like normally when you will be learning, so you will simply create only one container or two containers max to max. But what happens in the real time basis, the thing is what happens, we create different number of containers. Okay, if you I want to go down, and here is one container. Okay, and here is another container, and here is another container, here is another container. Suppose I have so many containers for a single project. Okay, so let me just create one more like this. Okay, it's fine. Suppose this is the project which have like project. Okay, I have one project here, or one application. You can say, instead of project it's better to call it application. One application is there, and I have so many containers here. Like these are the containers which you can think of. Okay, so these containers are already there, and what Kubernetes will do, Kubernetes will like it will help in deploying all these containers, scheduling, scaling these containers locally, or local on locally, or it can be on cloud. Okay, basically we not we scale in cloud, not locally. Sorry for that. So Kubernetes, what Kubernetes will do, it will basically do deployment of these containers. It will schedule, and it will scaling, like help in scaling everything like required, like monitoring is also there. Okay, So what Kubernetes will do, Kubernetes will take care of all those things of a container, okay, of these number of containers. So like later in the videos we will learn about pods. Pods are one of the thing which is important to know. So pods is nothing but in a one pod we have with so many containers, one storage volume we have. So like we will discuss these things later, like in the upcoming videos. So what is the pods and what are the other concepts? So here the main concept of the Kubernetes is to maintain the deployment of the containers and how we can scale these. So basically to manage the containerized application. That is the simple concept of Kubernetes. Okay. So in this case, suppose we I have already told you like so many containers if you have. So what we will do, we will basically with the help of Kubernetes, what will happen. So if I take this image of Kubernetes and if I just put it in middle of that, sorry. Huh. So if I just put it here in that, so and these are the some containers. So what it just shows, so it shows us the all those thing management of the containerized application. If you go upon the chart here, so here you can see manages containerized application. So how it manages? So with help like this it manages like in the in deploying, scheduling, scaling, and also load balancing is also one of the important thing. Like load balancing is also the Kubernetes is also used to manage the loads between the containers and all those things. Okay. So this is the overview of the introduction to Kubernetes. I hope you liked it. And now in this class we will look at the basic architecture of Kubernetes part 1. So this is the part 1 of this architecture video, and in this we will be covering about the overview of the Kubernetes components, the basic architecture, and what is the master, worker, node, pods, and cluster. These things which we are going to cover in this particular video. So before starting this, I want to ask you one question. Like, if you worked in a team, so in a team which we have some of the components, like we get one manager, some team members, and the manager is responsible for managing his whole team. So on the same basis, on the same criteria, the architecture also works, that Kubernetes architecture. So here I have one image for you guys. So here you will see the manager is there and here some three persons are there. So manager and all person is making up one team. Okay, so manager is responsible for managing and coordinating with these person or these team members. So in a similar case with the Kubernetes architecture as well, the manager is get replaced with the master node and the persons is get replaced with the worker nodes. Okay, so these three are the worker nodes and the whole thing makes up as the cluster. Okay, so this is the cluster which is made up with the master node and the worker nodes, and in the worker node we have these things. I will describe it with you what are all those things. Okay, so I hope it is clear to you what is the master node and what is the worker nodes. Okay, so we will go deep down into this about the worker nodes and all the cluster. So this whole thing is called as the cluster. I hope it is clear. So here I have some notes on the cluster, what is the cluster and all those things. So here you can see the first point which we are covering is the master node is responsible for managing the cluster, and also whenever we deploy the Kubernetes then we get a cluster. Okay, it's correct. And what is a cluster? If someone asks you what is a cluster, so cluster is nothing but the set of machines. Okay, here you can see that is called nodes. So these are the nodes. This is the node 1, this is node 2, this is node 3. Okay, and if you go further, here you can see there can be more than one master node in a cluster to provide a cluster with failover and high availability. So here you can see like here we have only provided one master node. Okay, but in the real life scenario we can have multiple master nodes in a cluster. So because if one cluster fails or one particular machine or particular node fails, then other can be used. So it just useful for the application or whatever the container or whatever the cluster is there, it should work always. That's why the high availability should be there. And also here you can see the multiple cluster in Kubernetes architecture. It is also possible, like multiple cluster is also possible in the Kubernetes architecture. We can have cluster 1, cluster 2, cluster 3, and also in clusters we can have multiple master nodes and all those things. Okay, so this is the some of the basic information about the cluster. And also now we will deep down into these pods. Okay, so here you will see some of the points on nodes and pods. So here you will see what is a node. So a node can be a physical machine, a virtual machine, or virtual machine on the cloud which we run on, like EC2 instance, like VM, Windows VM, Linux VM on AWS or Azure portal, which we do. So it can be anything, like a node can be anything, and each node in Kubernetes contain one or more pods. So now let me describe you these things. This is the pod. So what is pod? So pod is nothing but uh, like in each the worker node or in each node the pod is there. Like here you can see uh, each pod contains one or more containers, and containers are responsible for running the actual containerized application code, while pods provide a logical host for those containers and manage their shared resources such as networking and storage. So actually what happens, like in our previous class we have talked about, like one application can have the multiple containers. Okay, so what happens, like when we do deployment and all, so while in worker node we can have the multiple pod. Okay, so in multiple pods, and in each pod there can be the multiple containers, and also here with containers we get one storage space as well. So there is a big concept about this all pod thing, like they share the same storage, and also the all the containers are there, whatever the containers are there, they share the same storage as well. Here we get one volume as well. So they share the same storage, and also the same network is being shared with within each each nodes. There is, suppose there is one pod. So if you will look at here, so here we have three pods. Pod 1 is there, pod 2 is there, pod 3 is there. So everyone will have the IP like 10.0.0.1, 10.0.0.2, 10.0.0.3. So like they work on the same network as well. So this is the like basic architecture of the Kubernetes. Hey, now in this class we will look into the architecture of the Kubernetes part 2. Okay, so basically in this class we will go deep down into the architecture, and also we have already covered the first part of the architecture in our previous class, in which we had discussed about the master node and the worker node. So now we will just go a little bit deep down into that, and we will see what we will do today. So here are some of the topics which we are going to cover. So basically the first topic which we are going to cover is the components of the master node, and the second one is which we have the worker node. So I hope you are aware of the master node. Okay, so master node is basically used to manage the cluster and doing all this stuffs. Okay, so let's start with the first topic. So here you can see the one image which we have is the master node. It represents the API service scheduler controller, and this is etcd. So you might be thinking, what is these all things? Okay, so basically the API server, scheduler controller, and this etcd is nothing but the components of the master node. Okay, so master node is not the single thing. Like inside that we have four components. So about all these four components which we will discuss in this particular class. So let's start with the very first one, that is, and the very important one which we have is the API server. So what is a API server? So API server is nothing but the very first component or the very important component of the master node. Without that, you will be not be able to access the cluster, that the actual Kubernetes cluster. If you want to access the cluster from the outside using your machine, then you will go through the API server. Okay, why? Because API server provides the interface. Okay, it just provides you the interface. Okay, like it may be like UI interface. Okay, or using command line tool also you can do. You can access the Kubernetes cluster. So here are some of the points which are mentioned. You can see like it is the main gateway to access the Kubernetes cluster, and also it is a central component of the Kubernetes control plane. So now you might be thinking, what is this control plane? So it's nothing but it just represents your master node. It means the control plane is simply means all the set of components which are used to manage the cluster. So obviously master node will be the one.
Okay. And the third point which we have, you can see here, the exposing APIs which allow user to interact with the Kubernetes cluster. So it simply means like making the Kubernetes API server accessible to other components such as client tools or web UIs. Okay. So exposing API is just that simple. Okay. It means that. And the tool which we use to access is kubectl or web uis. Okay, it can be used to interact with the api server, and it is also responsible for validating the request. What does this line refers to? It simply means whenever one client will request something from the API server. So it will first validate that request, whether that request is valid or not. Okay. So after validating the request, that request gets approved, and then the client should be able to access the thing or do whatever operation they want to do. Okay. So this is about the API server. I hope you got it. And then next, moving forward, we have another one is scheduler. Okay, so here you can see the scheduler. Scheduler is nothing but, as the name suggests, here you can see a scheduler is nothing but which is used to schedule the pods. Okay, so basically what happens, like here you can see the first point, like responsible for scheduling pods or nodes. What does it mean? It simply means like whenever a new pod is created in Kubernetes, so what happens at that time? A scheduler selects a node for the pod to run on. Okay. So what will happen whenever a new project, whenever a new pod is created, okay, when a new pod is created, and then after that, what will happen? Like it is not like randomly going and work on some particular nodes. So like you have seen in our previous class, here we have discussed like in the worker node we have pods, and in pods we have containers. Okay, so here it's removed actually. So here we have suppose containers. Okay, so what happens, like scheduler, what it does, the role of that is it just checks the what is the requirement of the pod and what are the specification of that pod, and then it decides on which container that pod should run. So that is the main work of that scheduler. Okay, I hope you got it. And also like some of the points is there, like the scheduler obtains the information from the etcd via the API server. So whatever the information should be there about the specification and the configuration, they access it from the etcd. Okay. And moving forward, we have the control manager. So control manager is nothing but, as the name suggests, you can see it just controls the or manages the cluster. It means monitoring happens there actually. So in that we have the kube control manager, which is responsible to inform the node. Like suppose in the cluster, if some node fails, so what should they do? The kube controller just sends the signal to the master node, and then whatever the action should be done, it is performed. Okay. So in Kube Control Manager also we have four controllers. We have like node, replication, service, and endpoint controllers. So these controllers actually work in the work not separately, they work together. Okay, so the node container, all these four containers work together, it's a single unit. So here are the some of the points, like node control what it does. So node control is basically used to monitor the nodes. Suppose if any node fails, then it just sends the report to the master node. And the replication controller is this maintain the current replica count. It means like maintain the current replica count. It means, so the thing is like what happens whenever user creates a pod, or whenever they deploy one pod with a specified number of replicas. So at that time, what happens, the replication control ensures that this desired number of replicas is always maintained. Okay, suppose you are a user and you are going to deploy one pod, and at that time you just you also mention that that number of replicas should be there. Suppose you are deployment one pod and you are giving it like three replicas should be there of that pod. Okay, so in that case, what should happen? If that replica should goes down, like suppose one fails, then replica remains two. So then that replication controller came into the role. It then again try to restart that pod and that replica, and then it maintains. Okay. And the service control is nothing but it just check whether all the services are properly configured or not, and the endpoint control is just to make sure all the endpoints should be accessible and it should be working. So this is about the control manager, and the last one which we have is the etcd or 8cat. You can pronounce anything whatever you want. So it's nothing but the key value database. It is basically just like a log, like whatever the event happens in the cluster, like suppose one pod fails and then one pod starts, or the node fails, node starts, node created, pod created, whatever the thing happens inside the cluster, it is just recorded into this etcd database, and it's actually a key value pair database. Okay, and it can only directly accessed by the API server. Okay. Okay, so this one is the whole thing about the master node, components of the master node. Now moving forward, we have the worker node. So in the worker node also we have some what we see in worker node also we have some, sorry, I did something, I guess. Wait. So in worker node, we have kubelet and kubeproxy. So these two exist. So we will look into it, how this thing actually works. Okay. So kubelet is nothing but like it runs on each worker node. Like this is one particular worker node. Okay. So that kubelet runs on every worker node. Similarly, like the pod which is there on the worker node, in the same thing, kubelet also works on the every worker node, and it is basically used to manage the state of the pods. Okay, pods, running pods. Okay, like whether it fails or whether something happens to the pod, it just reports to the master node. Okay, so basically how does this thing work? So it basically works based on this pod specification. Like it is nothing but it is defined in the JSON or YML file, and inside that we get some parameters, like we get the metadata, specification, and the state. These fields are present inside that JSON or YML file, and based upon that, kubelet decides what to do. Okay, so and also it makes sure whether containers with whatever the container which are running inside the pods, like here you can see I have one container. Just suppose you think it like as the container, and this is one pod. So like kubelet make sure like every container should be running always. And we have kubeproxy. So kubeproxy is nothing but it is responsible for managing the networking aspect of cluster and the network configuration and the rules. So suppose networking things like IP addresses, DNS, all those things is managed by the kubeproxy. And the last one which we have is the container runtime. So container runtime is nothing but the software which is responsible for running the container. So actually Kubernetes does not provide the some direct way to run the containerized application. So that's why this container runtime came in the role. So this is basically nothing but the Docker. The Docker is the most famous and the most preferred and the most used containerized app software which we used. Okay, so there will be Docker. Okay, so this is all the things. I hope it is clear, like all the components of the worker node and the this one master node. Okay, so I hope you got it, everything whatever we have discussed. If you have any question, you can ask us. So now in this class, we will talk about the Minikube and the kubectl. So these two tools are very important for the Kubernetes industry and inside this Kubernetes industry. So before starting the introduction of the Minikube, let me tell you about some idea about what exactly happens in the production environment or in the real world. So in the real world, there will be like many master nodes and the many worker nodes. Just like here you can see in the picture, we have two master nodes and we have different worker nodes, like three worker nodes we have currently in this scenario. Okay, but it can be more and it can be less as well, but not it will not be easier for us to just create one cluster like these kind of. Suppose like the thing is, the node here refers to what? The node here basically refers to the virtual machine or the physical machine. So if you are learning Kubernetes, for you it's not possible to create those kind of to create the virtual machines inside the cloud in the instances like Amazon EC2 instance, or if you will use Azure, then there is virtual machine. So for you it's not possible to do all those things and create one cluster and everything. Okay, So that's why for the testing purpose and the learning purpose, Minikube came in the role. So what is a Minikube? Minikube is nothing but a single node cluster. Okay, here you can see I have written the definition for you. It's a one node cluster where the master process and worker process both will work on a single machine. So here the single machine means on your particular system. Suppose if you want to if you are learning on your Windows PC, then there will be you will install the Minikube and then you are good to go to learn about the Kubernetes. Okay, so here in the Minikube we are getting this master process, worker process, and also one benefit is that you get Docker pre-installed with that. Okay, so when you will install Minikube, then you will get Docker pre-installed with that. Okay, so also the thing is like for using the Minikube, you should have the virtualization enabled. Okay, it's like compulsory to work virtualization should be enabled. Okay, and also let's see the how actually it works. So suppose this is your host OS can be your Mac or Windows or the Linux. Okay, and then in that there will be VM, and after that there will be the Minikube. Okay, on that we will install the Minikube. Okay, so this is the overall idea about the Minikube. Okay, so and now let's see about the kubectl. So kubectl, as you are aware, it's nothing but the one of the command line tool which is used to manage the cluster. Okay, so this is the like basic definition of the kubectl. So in our upcoming class we will install the Minikube and all those kubectl in different OS. Okay, so I hope you got it. If you have any query, you can ask us. Hey, now in this class we will see how we can install the Minikube and kubectl in the Ubuntu machine. So here I have written all these steps which are required to install the Minikube and kubectl. So before installing the Minikube, you should have Docker installed already. Okay, otherwise if you have not installed Docker, so you can follow the documentation and you can install it easily. And also like why we are using Docker here, because like Docker is easy to use and easy to like Minikube will work easily with the help of Docker when we will use the Docker as a driver. Okay, so also you can use VirtualBox, but there is little bit of complications and all. That's why we are not using VirtualBox here, because we are running the Ubuntu machine in VirtualBox itself, so that will be very complex process. So that's why we are going with the Docker. So let's start with the installation. So here what you can do, you can just search for the Docker install in Ubuntu. Okay, and you will get uh, here on the official documentation of the Docker. From here you can just follow. Like if you have already installed the Docker, then you can just copy up this command and you are just good to go. So I just demonstrate you. Actually I have already installed Docker, so let's do it. And then you can do just sudo apt get update. Then we have this one. You just have to copy and paste thing, that's it, and then you can install Docker easily. Okay, done. Next you have to do this gpg key. Okay, next this line you have to do curl command. Okay, wait a minute. Yeah. Okay, here actually it's asking me to overwrite, so actually we have already installed, so that's why it's showing. You can just put it yes, but in your case it will not ask you. And next what we have to do, we have to give the certain permission for that file, so you can just give it using this command. Next you have to use this command to set up the repository. Okay, done. Next what we have to do, we have to update, so we can do it using sudo apt get update. And then you have to install the Docker engine, so that's one is also important step. You can just do like this, done. And next we have to nothing, we just have to run this hello world command to check whether Docker installed or not. So here you can see Docker installed successfully, that's why you can just use the command Docker and check. So here you can see we are getting some of the information or what commands you will need to use. So just clear the screen. So with that we finally installed Docker successfully. Next, moving forward, we have Minikube and kubectl installation. So for the Minikube, sorry, here there is a mistake, like we have written VirtualBox, but here we need to write the sorry, what we have to write, Docker. You can write like this: with Docker setup, move on the installation. Okay, installing Minikube on your Ubuntu system. So what we need to do, first of all, you will need to download the latest Minikube binary by using this wget command. So you can just copy up this command. I can provide these in the comment or description section. Okay, just copy it and you can just paste it here, and it will install, sorry, it will download this file Minikube Linux AMD64. So actually I have already installed it, Minikube, and also you can, like, I will demonstrate you how you can do it. Okay, so it will take some time to download that file. Just let's wait and let's move forward. What we have to do next, what we have to do, you have to just copy this file to this directory, user local bin Minikube. Okay, so what, for that, what command you have to use, sudo cp. Cp is the command to copy, and then the file name and the location. So just copy it, and next you can just do that one, and you're good to go. Okay, and next what we have to do, we have to give the certain permission to that file. So we can do it like this: sudo chmod 755, done. Okay, you can check that as well. We will go in that directory, user local bin, and ls hyphen l. We let me just increase the size and let me just clear the screen. ls hyphen l, if we do, here you can see this Minikube. Okay, and it has the read write permission. Okay, this is the execute permission. Okay, fine, cool. So that part is done. Let's move forward. What we have to do, you have to check the version of that Minikube. So if it comes, then it means you have successfully installed the Minikube. So here you can see its version is showing this 1.3.30.1. Okay, you can just ignore this. This is just a warning, you have to just ignore it. Moving forward, we have to, what we have to install the kubectl. So for kubectl as well, also we will follow the same thing. We will just copy all those things, and then you have to just install the kubectl as well. Let me just come up on the home. Okay, done. So it will just fetch all those things whatever it's required, and next what you have to do, install the kubectl using this command, sudo install, and then you can use the kubectl easily. Okay, here you can go, and now let's check for the kubectl version. There also you can see it's showing the all those things like version 5.0.1. Okay, so here it's showing because we have not started the Minikube right now, so that's why it's showing me this error. Let me just close it. So finally we have installed the kubectl and Minikube. Okay, so let's see some of the things, like we will just start the Minikube using the driver. You need to provide the driver what we have to use. So driver will be equal to docker. Here you can see pulling base media starting existing docker container. So actually I had already made one container. So what we can do, we can just I will just delete those nodes. Okay, so it will delete, it will take some time, and then we will again create. Let's clear the screen, and we will just hit enter. So it will create. So keep in mind you should have two CPUs enabled, like in the system setting of your what we say, when you will go in the settings, and here you can see in the system, you can see in the processor tab, you should have more than two CPUs, like three CPUs. Okay, so these things you should keep in mind. Okay, so it's creating. Let's see. It doesn't take much time, like it's first time. In your case also it can take much time. Okay, so here you can see kubectl is now configured to use minikube cluster and default namespace by default. Okay, so it means like we can use kubectl now. Okay, so if we will check for the status, so you can check the status with this command status. So you can see all those things are running. So in this way we finally install the minikube and the kubectl.
Hey, and now in this class we will see about the minikube and kubectl commands. So I hope you are aware of what is minikube and what is kubectl. We have already discussed on these two topics in our previous classes. So let's start this particular class. Here I have the command example and the description. So we have so many commands. So we will see some of the commands in this today's session. So without wasting time, let's begin. Okay. So I have my Ubuntu machine running here. You can just open up the terminal with the shortcut that is Control Alt T. Let me just increase the size so that it will be visible to you. Okay, I hope that much is fine. Okay, so now the very first command which we see is the minikube start. Okay, so what does this basically command does? So as you are aware of what is minikube, minikube is the one node cluster which is having the master and the worker node both included in the one. Okay, so basically it will start the cluster. Okay, so when you will do the minikube start, it will take some time and then it will start. If you are running it the first time, okay, then it's fine. Actually I'm also running it for the first time, so it takes usually some of the time. Okay, so we will wait for it for the completion. Okay, so till then let's see some of the commands, okay, which we have here. So here you can see with the first command that we have is the minikube start. Here you can read the description, like what it does. It starts the local Kubernetes cluster using the minikube, like we had already installed it. And then using the stop, it stops the minikube. Then status, it will display the status of that particular cluster, and then delete and all everything. Okay, so let's see. Here you can see we have cluster created and minikube has been started. Okay, so here we can see about the further commands. Let's see if we do minikube status now here. Why it's not running? Minikube status. Okay. So here you can see the type is control plane, the host is running, kubelet is running, API server is running, kube config configured. Okay. So here you can just see some of the terms like API server, kubelet. Okay, all these terms like what you know about the what API server is now. Like we have already discussed it. Like if we use API server to communicate with the cluster. Okay, so here you can see using the minikube status command, you can check the status of the cluster, what's the current status. If you will do minikube stop, so it will just stop the cluster if I do it. So let's see what it does. Here you can see powering off the minikube. And also if you look at the table here, like we have delete, so it will delete the cluster. Okay, then we have IP, it will display the IP and SSH. Okay, so let's do all those things. So here you can see minikube is now stopped. If you will check for the status now, let's see what it shows. So here you can see everything is stopped now. So again, to start the cluster, what you can do, you can just enter the command like minikube start. It will again restart the cluster. Okay, like now it will not create the cluster, it will just restart the whatever the cluster which we had created just now with that command. Like this I was running first time, that's why it was creating the docker container and everything, like CPUs to memory, this much is required, all those things. Okay, so here you can see now it's just restarting existing docker container for minikube. Okay, so here you can see it's done now. Now if you'll check the status, so you will get it's running perfectly fine, everything is running. Okay, now moving forward, let's check the minikube IP command. Okay, so it displays the IP of that particular cluster. Like we use this IP for using some of the services like which we look in this particular class and further. Okay, so next we have is the let me check. Minikube SSH is there and delete is there, so we will not use delete right now.
till then let me show you SSH. So SSH is basically used to, it will connect to the virtual machine of that like minikube. Like whenever you install the minikube in your PC or in your Ubuntu machine, so at that time what happens, one VM is also created in that minikube. So with minikube SSH you can connect to that particular VM. So here you can write any Linux command which we use. Like here you can see who am I. So here you can see it says Docker. If you do like, if you want to create some file like cat test talk tst, this is a test file. So it will, if you do ls, so here you can see the file has been created. Okay, you can read file as well. So in this way you can use the docker. Okay, docker is like minikube ssh. So to exit you can just write the exit command and you will just log off. Okay, so you can use this minikube SSH also to connect to the Docker VM. Okay, or actually it is used for the debugging and testing purpose as. Okay, so moving forward, we have now we have covered all this minikube commands. Let me move forward in the kubectl. Okay, so what is kubectl? Like we know that kubectl is a command line tool that we use to communicate with the cluster. Okay, so you can use the command like kubectl version. Okay, sorry, what it says, command kubectl from snap kubectl snap info forward is the version. Okay, let me just check again. Just kubectl. Okay, fine, it's there, it's running. I think there was some mistake in the command. Okay, version. Okay, leave it. You can use kubectl to get the cluster info using this command. So here you can see you can get the cluster info, whatever the cluster is running, you can get the info. And also the important part here is that like for the running of the kubectl, your minikube should also run. It's not like your minikube is not running and then you are trying to run this kubectl command. So in that case it will not work. Okay, we will check that. If I stop the minikube, okay, it's stopping, and okay, let's wait. Okay, now when you will try kubectl cluster info, so in that case you can see you are getting so much of error, like the connection to the server was refused and all those things. So that's why we should have minikube in the background. Okay, so minikube is started again. Okay, so minikube has been started here, you can see, and now we can use kubectl again. So now let's see the table and we will do the we will run those particular commands. So here you can see kubectl get pods. What it does, it retrieves information about Kubernetes resources like pods, deployments, and services. Okay, so here you can see many things we have. Okay, also we have this create command. Okay, so it just creates the new deployment for Nginx web server. So what we will do, we will do this one. So how we can do it? So for that we have to just this clear the screen and let's run the command like kubectl create, and then we have the what we want to create, what service we want to create, deployment, and then we can just write the name, like we can write the deployment name as the nginx and the image which we want to use, like we want to image as nginx. So here if you are aware of the docker, then that time like that will be very helpful because the here image refers to that the docker hub images. Okay, so whatever the images you create and whatever the images you want to upload to the docker hub, and if you want to use those images, then you can use it from this, like using this command. Okay, so let's hit enter and here you can see we have this nginx created. If you will see for the kubectl get deployment, so here you can see we have nginx, it's not ready yet. Okay, so it's not ready yet. And also we can check for the kubectl get pods. So here you can see one container has been created. Okay, container creating, like it's creating. So what happens whenever you are deploying any kind of resource, like any kind of whatever resources? Okay, so at that time what is basically is happening in the background, like we have learned about the Kubernetes architecture, like we have the pods, and inside pods we have container running, and so many things like replicas is created, and that replicas is maintained by that the managers. Okay, so basically what happening is here, the same thing is here, like when you are doing the deployment, then pods is creating and the replica is also creating. So here when you use it by default without providing the replica, okay, so replica in the command, so what happens for that time, there basically only one replica is created. Okay, but when if you will provide hyphen hyphen replica is equal to whatever the number, then at that time what will happen, that particular number of replicas will be created. So this is the basic overview of this command. Okay, so let me again check. So here you can see the pod is running, and you can check for deployment also, it's also ready. So now what we can do, we can just expose this deployment as a service. So what does it mean? So basically we want to use this now Nginx servers, we want to use this Nginx server. How you do it? So for that also we have this kubectl expose. It's like we have this in the table. You can check. Here you can see kubectl expose deployment nginx type equal to node port. So here you can see what it does, creates a new node port service for a deployment named nginx. So basically the node port service, it simply means like that exposes the ports of the deployment to the specified ports. Okay, so we will define some of the port number, like here 80 is provided, but basically what happens, like whenever you try to get the URL, at that time the cluster basically defines their port between the 13,000 to some 32k thousand ports number. Okay, so this is the basic thing. So let's just run this command, and then we will be able to use the Nginx servers from our web browser. So how we can do it? Expose deployment, and then we need to provide the name of the deployment. The name of the deployment we have nginx. Okay, and then the type equal to node port. If we don't provide the port number, then also it's fine, it's not mandatory to define. So you can just hit enter. Oh sorry, it's mandatory. I thought it's not mandatory, sorry for that. Okay, we define some port equal to 80. Okay, now service is exposed, and now you can check for the kubectl get services. Okay, oh sorry. Okay, so here you can see now this nginx service has been created. Okay, and here port you can see this one. Okay, 80 3543, all these things. And now for getting the URL, what you can do, minikube service, and the whatever the name is there, nginx is there, and hyphen hyphen URL, it will give you the URL, and then you can access these things. So here you can see the port number which we are getting is 3543. Okay, so it basically what is happening, just a redirecting. Okay, so let's see where we go. Okay, here you have to just enter the URL, and here you can see the welcome to nginx is the web page, the default web page we are getting. Okay, so now just we will revert back to the things, like we will just remove the services, and then we will try to access the web pages. Let then see whether we are able to access it or not, that nginx web page. So to delete, the command is kubectl delete, and the resource, and that is services, and then the name is nginx. So here you can see nginx is deleted. Again we will come upon here, let me reload it. So still we are able to access. Okay, so let me just again check. Okay, it is deleted. Now we will just delete the deployment. So how we can do it? Deployment. Okay, so deployment is also deleted.
Now let's check. Okay, here you can see now we are not able to connect to that particular IP. So in this way you can use the multiple kubectl commands. Okay, we have so many like here. You can see kubectl logs and kubectl delete. We did delete right now. Let's check for the logs what it shows. Okay, log is there. I mean, did you mean logs? Okay, so here you can see expected what it's saying. If we do hyphen h, okay, we are doing something wrong, I guess. Okay, kubectl hyphen hyphen all containers logs in the pods. Okay, if we do control C and we do this one, so here you can see. Uh, okay, okay, let's see some of them like what we have here. Hyphen C. Okay, so let's check the pods what we have. Okay, okay, we have deleted the all the deployment. That's why we are not able to get the pods details. Okay, okay, got it. Okay, that's why we were not able to just get this output of that, and we were getting the error. Okay, so that's all for today's class, and I hope you liked it. If you have any query, you can ask us in the comment section. Hi, and now in this class we will see how we can deploy a containerized application using the YML file. So in our previous class we have done using the kubectl command and using the kubectl create deployment name. Using this thing we have done it. So now today we will see how we can do it using this YML file. So here is the basic structure of the YML file which we have here. You can just copy it, okay, or you can write the exact same which I have written here. So we will first discuss about this thing like what is this API version kind, all the we will go in the detail like I have already written all those things about all the specifications or the detail of each line here. So let's start with the first line here which we have is the API version. So here you can see the API version. So it simply defines the what version of kubectl you want to use. Like if you will do the kubectl version command, then you will get the a version of client and server. So there you will get some one dot something something. Okay, so therefore we are using version 1 here. Okay, and simply the kind simply means like what type of deployment you want to do. Means sometimes we create some service, so here we are just defining what we are going to do. So here we are defining like we are going to do a deployment, so here that's why we are using here deployment. And the metadata, and inside metadata we have this name, so we need to just provide the name of the deployment. We can give it anything like nginx or something like whatever you want. And then we define some specifications, like in that we have some replicas. So by default when you do it with the kubectl command, that time what happens, only by default one replica is created, but with the deployment file you can give any number, or like it's all upon you how much replicas you want. So this is about the specification, and here is all the details about the whatever the fields which we have. So here you can see about the selector. So what does it? This field specifies how to select the pods, like how the pods will be selected by the node, all those things. And the template is here we have. So they define the pod template and their metadata, and again a specification of the pod. So basically like what container will be used. So by default what happens, like from the Docker hub we choose the image. So we need to provide some information of that as well, like which image should be chosen. So here you can see like in the container we have the name should be nginx, and the image which we are using is nginx, and the latest. What is the latest here? So latest is nothing but the latest tag which is used while
when you fetch some image from the Docker hub, so there you will see like whether that image is which version of image is it. So if you will use latest tag, then by default what happens, like you get the latest image. So this is the overall like description of this YML file. So I have already created in my machine. So here I will come upon here and just enter the password in this Ubuntu machine, and you can just hit Ctrl Alt T to increase the to open up the terminal. And here I hope it's visible to you. What I can do, I will just show you the nginx that file which I have. So here you can see it's the same as which I showed you there. So it's same. You can just write as it is. Okay. So now we will see what is the command basically we use to just create the deployment with the YML file. So here you will see like we have this command kubectl create hyphen f, and after hyphen f we will provide the path of the YML file. So currently here if you will see, so I am in the like this in this directory, like it's the home directory you can say, and here I have this file. Okay, so what I can do, I can just enter kubectl create hyphen f nginx and hit enter, and you will see here we have got the output as the this deployment has been created. To check what you can do, you can just enter the command kubectl get deployments, and sorry, there is some mistake in the spelling, deployments. Okay, fine. So here you can see the deployment we have, and red is 2 by 3, and let me check again. So okay, here you can see all the deployments are ready. So in this way you can just create the deployment using the YML file. Okay, now let me just start this service. Okay, so how we start the service, this is simple. So it's basically using this expose. So how we will do it, using kubectl expose, and then we will just provide the name or like the whatever is this kind is the deployment, and the whatever the name is here we have nginx ng let me check again the deployment. Okay, here we have, let me just copy it. You can do just copy using control shift C and control shift V to paste, and then you need to provide the type is hyphen hyphen type equal to node port. This thing we have discussed in our previous class. Okay, if you're not watched, you can watch it. And we define the port equal to 80. So here the thing is basically why we use this expose. The reason behind this is like by default whatever the pod is there, that is only accessible by its internal IP address. Okay, that within the cluster. So when we want to use outside of that cluster, like in our web browser, so for that we just use this expose, and we define then ports and all. So let's hit enter, and the service is created. You can just check using kubectl get services, and here we have the nginx deployment. Okay, and internal IP and external IP is none. To get the external IP, what we do, so we do just a mini cube service and the nginx deployment, and you just need to pass the hyphen hyphen URL. And here we have got the URL. You can just copy this and you can just paste it here. So here you can see welcome to nginx, and it's working perfectly fine. And we can check for the pods kubectl get pods. So here you can see we have 3 pods running. And why 3 pods running? Because in the replicas we had defined that there should be 3 replicas. So that's why there is 3 pods are running. So to check the logs, so what we can do, kubectl logs and the name of the pod which you want. So here is the log of all those things. Okay. Hi, and now in this class we're going to see about the Minikube dashboard. So before starting the class, make sure your Minikube should be in the running status. So let me check. So you can check the status by using the Minikube status, and here you can see everything is running perfectly fine. So now let's start some basic thing about the what minikube dashboard. As you can see, the name suggests that dashboard. What does it simply means? It simply means one, so there will be a UI, you can manage some kind of things. So it's also the same thing, like minikube dashboard is nothing but a web-based UI interface which is used to manage the Kubernetes cluster. Okay, so now the thing is how you will use it. So for that we have the command that is minikube dashboard, and when you will hit enter, and automatically the whatever the default browser which you have, so in our case here we have Firefox, so this Firefox will open and you will come upon on the screen. So here you can see in the dashboard we have so many things, like in our last class we have deployed one pod, or one deployment was there, and we had three replicas of that, okay, that containerized application. So here you can see pods are there, replica set is one, and one deployment is running. So this is the workload status and the deployment. You can see the nginx deployment which we had done, and the three pods you can see here, replica sets you can see. So here you will basically get all the information and whatever thing which we have, and you can easily manage the cluster here as well. So here we have different sections, like here we have deployment section. So here you will see the deployment that we have, that is nginx deployment. And here you can see the age is a day ago, so it means we had done it yesterday. So this is the thing. And now which you will see about the node information. If you need, you will need to search for nodes. So nodes is there somewhere here only. Let me check. Wait, let me go on the home page. Okay, here you can see the cluster. In cluster we have nodes, so we have that minikube as it's a single node. Okay, so that's why we have this so many labels and all. Minikube is the node here. Okay, so in this way you can get so many information. Like here you will see about the CPU information, memory information, ports you have, so 12 ports we can, and all those things. So moving forward, if you will see about the pods, so if you will come upon here, like here you can see a service as well. So ingress we have not discussed, so will not cover right now. So here you can see the services which you had done, that is nginx deployment. So this is we have. And also if you want to create one or deploy one, want to do one deployment, so how you can do it, you have to just click on this create button, and here you can do using the YML file, or you will need to write the YML whole thing here. And if you want to do with the file, you can just upload the file. If you want to do with form, you can do with form as well. Here if I write the form as engine, what's that, nginx, okay, and the container image we have nginx. And here if I do -2 and just deploy, so you will see one deployment is pending, and it will take some time, and it will, yeah, here you can see now we have 4 pods, 2 running deployments are there, and 2 replica sets. If you come here below in the pod section, here you will see all the details. Okay, so this one is the one pod which just created. So because tag is not here, like in our previous class we had used tagged nginx and letters, so that's why it's like that. Hi, and now in this class we will see how we can manage the pods. So as in our previous classes we have shown, like when we were deploying some application or some containerized application, so at that time pods were also created, like we were defining how many replicas are needed, all those things like in the deployment.yml file. So now what we are going to do today, we will basically manage all the pods, how we can do it, and we will see what are the commands which we can use. So let's start. Make sure your minikube should be in the running stage. So let me just check the status, minikube status. By using this command you can check the status of minikubes, and here you can say it's perfectly running fine. Okay, so the first thing which we will do right now is we will just create one new pod. So there are two ways. One is using the command line, and other way is using the YML file. So the very first and simple method is using the command line. So how we can do it, just use kubectl run command, and then you need to give the pod name. So here I will give the pod name as nginx-3, and then the image which you will need to provide is this nginx, and it will create one pod. So In this way you can create the pod. And also the other way which we have to create the pod is uh, using YML file. But before that, let's check how like how many pods are there we have. So to check that, we have one separate command, that is kubectl get pods. So with this you can check how many pods we have. So here you can see the pod name which we defined just now is, that is nginx 3, and here you can see it's in running stage. Okay, so with this you can check the how many pods we have. These three pods are from the previous classes, and these two also. Okay, this nginx 2 is also from the previous class, and this one just right now which we created. Okay, cool. So now the next thing which we'll do here is how we can just create the YML file, and using that how you can create one pod. So it just similar to the previous class which we had done with the deployment with the YML file. So what you can do, you can just create one pod spec.yml. Okay, and inside that you will need to write the YML code. So how you can do it, it's very simple. The first thing which you need to define is the API version. So you can do like this, API version colon, and just give one space and version 1. This one is done, and you need to define the kind. It means what type of object is that, whether it's a pod or it's a deployment. So here you can just write the pod. Next we have some metadata, like we will define the name of the, what do we say, we define the name of the pod. So the name we can define as the nginx task 4. Moving forward, we need to define the specifications of the pod, like containers specifications. So there will be containers, and inside containers we can have the name of the container. The name I will give the here as nginx dash 4. Okay, this is the container name. And next we have image. So the image, what we will do, image we will be using this one same, like this. Okay, nginx is the image. Next we have to provide the ports. Okay, so for ports also the same we have. You can do define the port like this, container port, and the port will be 80. Okay, so now it's done. Like now what the thing is, here you are defining one container. Okay, and it's one. Again, if you want to define some other containers, you can just copy this thing and you can paste it here. Okay, like this is just array. Okay, so here you can just write some other images and all. Okay, so in this way you can just define multiple containers in a single pod. Okay, so now I just save this file, and what I do, let me just reduce its size. Oh, let me just close it. Okay, fine. So now what the thing is, how you will create with the YML files. So the command for it is kubectl create -f, and the name of the file, that is podspec.yml, and here you can see nginx 4 is created. Now when I do the kubectl get pods, so here you will see we have nginx 4. Okay, so in this way you can just create the pods, okay, using the command line or using the YML file. So it's that simple. So now if you want to check the log of some pod, so how you can do it, you have to just use kubectl logs and the name of the pod which you want to check. So I want to check nginx dash 4, and okay, we have written some spelling mistake. Okay, fine. Okay, so here you can see this is the whole log of that particular uh, pod. Okay, nginx 4, in that we have used nginx as the, what we say, here you can see uh, application or image is the right thing. Okay, so we have used nginx image in that container. Okay, so in this way we can get the logs as well. And suppose if you want to do like update in pod, so how you can do it, you have to just use the kubectl apply -f, and the whatever the specification file is there, you update there, and it will be updated automatically. Okay. And next also very important thing we have is the describe. So how we can do it? To describe any pod, it will give you more information. So kubectl describe pod, and the pod name what we have is pod name, let's take nginx dash 4, and here you will get the all the information like what's the name, namespace, priority, service count, and the node which you have is the mini queue, when it is created, what's the IP in the cluster, everything, and the container ID even, and the image, what is image has been used, image ID, port. So everything you will get when you describe it. Okay. And also here you can see the events, what are the events, the default scheduler here used to manage the pod. Okay, and the pulling, pulled, created, started, these all thing has been done by the help of kubelet. Okay. So now you can just relate to the concept of the architecture, whatever the thing was there in the worker nodes, what were the kubelet was there, why it was there, and also the scheduler which we had discussed. So different types of schedulers. So now you can relate it with all those concepts. Okay. So in this way you can just describe any pod, and also the last part which is here to cover is that is scaling of pod, how you can scale a pod. Suppose if you check for the deployment, let me check, let me just clear the screen, and the command which you have is kubectl get get deployment. Okay. So here you can see we have nginx deployment, and we have this one nginx 2 we have. So currently we have one pod. Okay, and in this we have three pods. So to scale, what you can do to scale, you have to just use kubectl scale, and deployment you have to write, because you're like doing in the deployment, that's why. And the deployment name which we have is I will do in this one deployment, and then you have to provide the replicas. So in the replicas, what the happens in that, when you will provide it suppose 2, so what it will do, it will delete one pod in that. If you provide 4, so it will create one pod. Okay. So it will create on the same configuration which is already there, like in which that other pods are running with that configuration. So same configuration will be used by the next pod as well. So how you can do it, if I do it 4 here and hit enter, and here you can see deployment scale. Now if I do get deployment, so here you can see up to date is 4, available 4. Again let me check, so here you can see 4 is there, means 4 pods are there now running inside that deployment. So if you do get pods, so here you can see we have 1 2 3 4 pods we have. So in this way you can manage your pods. And also the last one which we have is how you can delete the pod. So to delete the pod, the simple command which we have is kubectl delete, and the pod, the keyword, and then pod name, which what is the pod name, I want to delete nginx dash 3. So here you can see pod is deleted. So that's all about the managing of pods. I hope you liked it, and if you have any query you can ask in the comment section. Hi, and now in this class we will see about the Kubernetes services. So basically we will start with the what is the Kubernetes services and why we need it, and some of the types of the Kubernetes services which we have. So we will see all those information in this particular class. So let's start with the Kubernetes services and why we need it. So basically you may have like not may, like you have heard about the pods. What is pods and how it is created and how it is replicated, how it is deleted. Everything we have covered this. So whenever you create a pod, whenever you run an application or a containerized application in a pod, so that time what happens, like sometimes you see like some pods may get deleted. Okay, some pods may be created, some replication is there. So at that time, whenever something happens, some if suppose some new pod is creating, then at that time a new IP is generated. Okay, and suppose one pod is deleted, then that pod is deleted, and at that place one new pod is replaced. Like that pod is replaced with the new one. Then that time also a new pod or new IP address is created. Okay, so to running the application, like all those things, like it will be very tedious to manage all these things. Okay, so that's why Kubernetes services came in role. It what happens whenever you create a service, so it assigns unique or separate IP address to that, and everyone will communicate with that IP address. Okay, using that IP address, they can communicate easily between them. Okay, so here you can see the definition which we have. Like in Kubernetes, the service in an abstraction layer. Why abstraction layer? Because like whenever an external user will come and request, so he will not be able to see how pods are running and what are the applications are running in that pods and how things are going on. So that's why it's like an abstraction layer, like hidden part. Okay, if you have heard about the oops concept, then you can relate it to that. Like the whatever the working should be the hidden. That's why it's the abstraction layer we have here. Okay, so now moving forward, here you can see like it provides a stable network endpoint for accessing the applications and ensuring that they can reliably discover and communicate with each other. So all these things which I just discussed now. And the important thing which we have here is labels and selector. What is labels and selector? So these are nothing but these are used to identify the pods. Okay, whenever we get the request from the external or any application or within the cluster, so that time it is important to identify for which pod that request is coming for. So that time we use the label and selector. So we assign label to each pod. Okay, so as you can see, we have assigned app a to all these pods, and we have selected as a. So suppose if request come for a, then it will redirect to any of these pods. Okay, if we are using load balancer, then it can redirect to any of these pods. Okay, so this is the concept of labels and selectors. Now moving forward, which we have is the Kubernetes types, like not types, Kubernetes services types. Okay, so the first service which we have is cluster IP. What is this? So it is just nothing but it is the default one. Whenever we create a service, then the default IP is assigned to each node. And okay, so here you can see what is the definition which we have. Like it's a default type in service. It exposes the service on a cluster internal. So basically, it provide us the internal IP address. Okay. So here you can see that is only reachable within the cluster, and it enables communication between different pods within the same cluster. So whenever like it is created, like for each pod, a new IP address is assigned. Okay. So here you can see an example. If we have like an example could be a database service that should only be accessed by other services within the cluster. Okay. So this is about the cluster IP. Moving forward, which we have is a node port. So what is node port? Node port is very important, very, very important. So node port service, what happens in this case, like currently which you saw ever with the cluster IP, with that what is happening, we are just able to access the application or ports can only within the cluster, not outside that. So to access the application outside the cluster, what we need is the node port service. So with this you can simply access the application from your browser. Okay, so here how things are working, suppose this is the in a cluster we have some nodes, and it assigns the some ports to that particular all the nodes. Okay, and based on that labels and selector, whenever the traffic comes to that port, that node, so it can just based on the nodes sorry, based on labels and selector, it just redirects the traffic to that particular application. So here you can see read all these things about. And also one more important thing here we have, that is for the nodes, for the ports which we have, that only port which can be assigned is between the 30,000 to 32,767. That is the range in which only the ports can be assigned. Okay, so this was about the node port. And the next one which we have, that is the basic one, that is the load balancer, which everyone is aware of. Maybe like load balancer is nothing but it is basically used to manage the load. Suppose there are so many traffic, suppose so many traffic, like usually you have 1000 traffic. Okay, but suddenly it increases to 1500. So at that time what will happen, at that time it will just redirect the load to different applications. Okay, like suppose pod 1 is handling 500 users, this one is handling 500, this one is handling 500 users. Okay, or this one is handling 200 and this one is 100 handling 600. Then in that case, this is on this server or on this pod there is low load. Okay, so then what happened, the load balance will just transfer that load to this particular pod. Okay, you can just read this definition what we have here. Like this service type assigns an external IP address to the service. It distributes the incoming traffic across multiple nodes. Okay, that the thing which we have covered. Like here you can see, for instance, if you have a web application, a load balancer service can distribute the incoming web request across multiple pods running the application. So with that load balancer, we will have the feature of scalability and redundancy. And last one which we have is external name. It's nothing but the alias name. Okay, suppose some service is there, and which you don't want to expose it to the externally, so at that time you can use external name. Like it will just suppose you want to use www.google.com, and you can just assign it to the assign to as my search engine. Okay, so this is the concept of external service. You can read this type of service used to provide an alias or redirect to an external service outside of the cluster. It allows you to use Kubernetes service to refer to an external service by its DNS name. Okay, so example, you can see you can create an external service called this, and that points to this. Okay, so it's just like allies. Okay, so that's all for today, and I hope you understood it. If you have any query, you can ask us below in the comment section. Hi, and now in this class we'll see about the implementation of Kubernetes services. So we had already discussed about the cluster IP, load balancer, node port, and external name services. Okay, so currently in this class we will see the implementation, how you can do with the commands. So before starting the video, let me just check the status of the minikube. So it might be running. Okay, so it's running. So you can also check in your case by typing this command, that is minikube status. Okay, moving forward, what we have to do, first of all, we will create one deployment. We will do one deployment. So how you can do deployment using kubectl? So we will do kubectl create deployment, and the deployment name I give today web app, and the image that I will use is nginx. So okay, I forgot to write this hyphen hyphen. Okay. Okay, image is created. Now we can just check the deployment using get deployment command, and also we will check the pods. So here you can see web app pod is has been created, like one is running, so only one pod has been created for that single deployment. Okay, so now moving forward, what we have to do today is I will first show you one picture. So here you can see that I have these four service types and what services we can expose to the outside world. So as you know, cluster IP we cannot, node port yes we can do, and load balancer we can do, external name also we can't do. Okay, so let's see how we have to do. So the first thing which we do is that is cluster IP. So as you know about the cluster IP, it's created by the default. Okay, so now first of all we will check what are the services we have already. So kubectl get services, if I do, so you can see I have only these two services. Now what I am going to do, I will just create one what type of service we can say, cluster IP service if I do. So how you can do it, but we cannot expose it to the outside world. So to expose that cluster IP service, the command which we have, that is kubectl expose deployment, and the name of deployment we need to use, that is in our case we have web app, and then here we will not define the port. Sorry, port I'm saying. Here we will not define that type, what type of service we want to expose. So if you will not define it, so by default it's cluster IP. Okay, so if I do it, so let's check again the get services. So here you can see the type which we have, that is cluster IP. Okay, so this is the cluster IP, the type which has been created. Okay, that service. Now in the cluster, like if there are some other pods as well, then they can communicate to using this IP. Okay, so now moving forward, we have that is node port. Okay, so what we can do with that? Okay, and how we will do it? So let me just clear the screen, and again I will be using the same command, but here instead of uh, like we will add one more flag, that is hyphen hyphen type, and here we need to define the type is node port. Okay, so where the type will be node port, and if I will do hit enter, then what that service is be, that service will be created. Okay, so here let me tell you something, like here the port which you are seeing here, that is port equal to 80, it means like you are that your application, whatever the application is running, that is running on that port number. That is like here in our case, that is nginx. So nginx basically runs on port 80. So that's why we are defining here that our application is basically running on port 80 in the pods or the container. Okay, and here we are defining the node port service. So what will happen for the node port, we get the ports assigned between 30,000 to 30,000 32,667. Okay, so between these two, that port will be assigned. So if I do hit enter, so here you can see web already exists. Okay, no problem. So what we can do here, I will just use dash and I will write a node port. Okay, so okay, sorry, expose deployment web app. Okay, yeah, I forgot one thing. See, we need to provide that hyphen hyphen name equal to web app hyphen node port, and here you can see service exposed. And if I do get services, so here you will see web app node port. Okay, so here you can see that type is node port and the name of this service is this web app node port. So now what we can do here, now we can just check the what URL has been assigned to that. Like, because of node port service, we can access this outside the world. It means we can access it using our browsers. What are the URLs? How you will check the URL, and what is the IP address? All these things, how you will check it. So here you can see the first which we have, that is port number, is this one they have assigned, that is 32,000 to 49. Okay, so now what we can do, actually this is we are doing in minikube. So in minikube we can check the IP address using this minikube IP. So this is our IP. Okay, so using this IP only we can access that particular service. So what will happen, what we can do, we can just copy this, and let me open up this Mozilla Firefox, and I will just hit enter, and I will paste the 322249 was that, I guess. Yeah, so here you can see that default web page of Nginx is coming on the screen. So in this way you can access the whatever service you want using this particular IP. Suppose, and now suppose if you are in the like working environment, or there are no only one node and one master node and one worker node. So what you will do in this case, so in this case you can use this command, that is minikube service, and the name what we have is here web app, service name is web app node port hyphen hyphen URL. Okay, so this will give you the URL. So this is the same URL which we have used just now. Okay, so in this way you can use the node port service as well. So that was very easy actually. So, and let me tell you some story behind it. What actually happens when you create this service. So suppose in your cluster you have 2 to 3 nodes, like worker nodes. Okay, so at every node, what will happen, at every node that port will open, that current port which you are seeing here, that is 32,249. So what will happen at every node, that port will open, and then whenever someone request, so whenever someone requests to that particular your service, so it will be redirected to the Kubernetes service, and then Kubernetes service will decide to which pod or to which like whatever service they have to provide. Okay, this is the like some stories. So actually notepad is also considered as like not secured. Okay, because it opens the port, and suppose some malicious user come, then they can access that port, and some information can be like what we say, the word that is ransomware or something like that. Okay, so now moving forward, what we have to do here is we will talk about now, that is the load balancer. Okay, so we have already discussed about the load balancer. So how you can expose that load balancer service. So this is the same thing which we do. We have to just we have to just change the name here. That name which we have, that is load balancer, and the type which we have is and the type which we have is load balancer. Load balancer service exposed. Let me check the services. So here you can see web app load balancer is the service created, and the here you can say it's pending, because we it's not like load balancer is not here, like we are just doing it all these things locally. That's why it's showing external IP as none and pending. Okay, So moving forward, what we can do, let me just again check the IP of my Minikube. What it is? Okay, this one. And here you can see the port number which is now assigned is this one, 30,317. So if I will do this, change the port number, then also what we can do, it will just come on this screen as well. Why this? Because like we are accessing this on this particular port, but our whatever the thing is, it is redirecting to that particular pod which is running this service. So that's why it's happening because of Kubernetes service. Like it is all being managed by that service. Okay. So now the last one which we have, that is external name. So let's see how we can do it. So what we can do here, so for the external name, what we do basically, we cannot directly like do here because we are doing in this what we say in Minikube. So as it's locally, we cannot do, and we cannot expose to that outside world as well. So I have a file which I have created already. So here you will see if test.yml. So here you can see how you can just create that particular service to that external name, exposed to that external name. So here you can see in the place of name, you can write that whatever name you want. Okay, like whatever the name. So whatever the name of service is here, okay, and in the external name, you can define the whatever the external name or external some domain name is there. Okay, you can write like that. Okay, so then internally it will work. Okay, so to implement that, you can just use this command. Okay, so in this way that external name service will also be exposed. So that's all for today's, and I hope you like this, and if you have any queries, you can ask us in the comment section. So thank you for watching, and I'll meet you in the next video. Thank you.